physics. It's a while ago for some of us. There are 4 fundamental forces in the universe. There's gravity, the strong and weak nuclear forces, and then there's electromagnetism. And what the electromagnetic force is it's the way that charged particles interact with, electric and magnetic forces or particles or waves. And what RF is it's an electromagnetic wave. Kind of like this. So this is the electromagnetic spectrum. And there's one thing really important that I want you to pay attention to, because there will be a quiz. It goes from lower frequency to higher frequency. Inversely is the wavelength. So if you have something that is very high in frequency, it's a very short wavelength. And if you have something that is low in frequency, then it's got a very long wavelength. Kind of like that long space, small space that our first speaker was talking about. And the really cool thing about this spectrum, notice everything that's on it. Everything from radio waves to microwaves to light. Visible light is all a part of the electromagnetic spectrum. And it all moves at the same speed. Everything on this chart moves at the speed of light through a vacuum. Does anyone know what this is?
Yes.
Good job. This is the Big Mac Daddy antenna. Actually, it's the second Big Mac Daddy antenna. So this is Arecibo. It's in Puerto Rico. And up until 2016, it was the largest single aperture telescope in the entire world. They lost out when China built their 500-meter telescope. So Arecibo is 1,000 feet in diameter. And it is the source of my very favorite space fact. When they originally built Arecibo in the 1960s, they were only going to go up to 500 megahertz. Now, if you remember that spectrum that I just showed, 500 megahertz is kind of on the low end. Remember when I said there'd be a quiz? That comes right now. So if something is on the lower end of the frequency spectrum, is the wavelength going to be longer or shorter? Longer. Now, Arecibo is used for radio astronomy, atmospheric physics, even radar astronomy. And yes, radar and radio astronomy are 2 slightly different things. So what fancy material do you think they have on the telescope to have radar in space? Is it like vibranium? Is it super smooth? It was chicken wire. Literally 1/2-inch galvanized wire mesh. And why? Because of that wavelength we just talked about. Think of it like your kitchen colander. If you're trying to catch sand in a colander, it doesn't work, right? The sand passes right through the holes. At least if you've got my cheap ass colander, I don't know which one. But if you're trying to catch golf balls, it'll work, right? Because the resolution of the mesh on the colander is that much smaller. So for 500 megahertz, the math actually works out to 2 feet in wavelength. 2 feet is a lot bigger than 1/2-inch mesh, right? So that's how that works. Isn't that cool as shit?